Alright, so this is the last video for assignment number 56, which is Pedigree Practice. So here you're going to practice assigning genotypes to two different pedigrees, and then you're going to actually create your own pedigrees and assign your own genotypes on your own. So if you look here, you need to figure out which characteristic is dominant, right? The shaded one or the open one, and then you'll need to choose a letter. We're going to use the letter B and assign genotypes. Remember that recessive individuals are always homozygous or purebreds, so it's actually easier to assign their genotypes first. Then you go back and you look at all the dominant individuals and assign them. All right. Some of the individuals we actually might not be able to assign their genotype with 100% accuracy, so we'll list both possible genotypes for those individuals. All right. So if we look at the key first, we have white females. All right, we have white shapes and we have black shapes. And so we have to determine which color or which allele is dominant. All right, so we just simply count the black shapes versus the white shapes, whichever one we see more of, right, is the dominant one. So if we look, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 black shapes, and there are only 7 white shapes. So we're going to say that black is dominant, white is recessive. And so we're going to say that this is the female will have 2 lowercase b's, and again the male will also have 2 lowercase b's. All right, and then the black shapes, they could either be 2 capital B's or they could be capital B, lowercase b. All right, and so as I mentioned at the beginning, it's easier to assign recessive alleles first, right? Purebred recessive. So if we look at our first family, all right, up at the top we have a square and a circle. They had 4 offspring, and one of their offspring, a girl, was white, so that means she has 2 lowercase b's. And if that's the case, if this female has the recessive gene, she must have got 1 allele from each parent, so then that makes each parent carriers or hybrids. All right. Now, if we look at the other 3 offspring, the 1 male and 2 females, they're both shaded in black. We don't know what they are, and so we're just going to kind of bracket them off and say that they could either be homozygous dominant or they could be hybrids. And the only way we could find that out is if they have offspring and one of their offspring also has that recessive trait. All right. Now let's go over to the right. We have a male and a female, and the male is white, so we have 2 lowercase b's. And then we also notice that there are 2 female offspring that are white fur, so they have 2 lowercase b's. And if that's the case, we know that the father can only give, or the male can only give 1 lowercase b, so that means the female must be a hybrid or a carrier. And if that's the case, then the other 2 siblings, the 2 males that have black fur, that means they got 1 dominant one from mom and 1 recessive one from dad. So this would be their genotype. And then finally, our last generation, or the second one, we have a female who's purebred recessive, and we have a male who is a hybrid. And if we look, they have 3 offspring that are white, so that means they're all purebred recessive. And then the 1 female that has black fur must be a hybrid or heterozygous. Right. So let's take a look at the next example. I'm actually going to go back to this. All right. And so this pedigree shows individuals with red-green color blindness, which I had mentioned in the last video. It's a sex-linked trait. So again, that means the male, if they have the recessive allele on their X chromosome, then they actually have that recessive trait of red-green color blindness because they don't have an opposing one on the Y chromosome because it's too small. So we're going to use the letter R, and we're going to assign genotypes. And again, it's easier to start with homozygous recessive first. All right. So if we look, all right, any female. Hold on one second. All right. So females are circle shapes, males are squares, And if they're totally shaded in, we're going to say that that means they have the recessive trait. So we look at all the shapes that are totally shaded in, and actually in this case they're all squares. So we can label every single one of those with just one lowercase r, because again, this is a sex-linked trait. So this means the males all have that recessive allele on their X chromosome, and they don't have an opposing one on the Y chromosome. Okay. So once we have that, then we can actually go back, and all the half-shaded individuals, those are females. Oops, I'm sorry, we missed one female down here at the bottom. That's totally shaded in, and if it's a female, that means she has 2 recessive alleles. All right. Now we're going to go back and do all the half-shaded individuals, which those are hybrids. So those are all females with a capital R, lowercase r. My stylus is not working very well, sorry. All right, and then you just go back, all right, and start in your first generation. So if we have a male that has red-green color blindness, marries a female, and they have, if you count, they have 1, 2, 3, 4, 5 offspring. 2 of the females are carriers. That means they get a recessive allele from the father, and that means the mother must then be purebred dominant, because all the other males, right, do not have red-green color blindness. So that means mom must carry 2 dominant alleles. And then the females are carriers because they got 1 recessive from the dad, and then they get a dominant one from the mom. So we're going to say that all the males only have 1 capital R because they got it from mom. Okay. Now we're going to look at the couple here in the middle, the female. All right, that is a carrier. A circle. She married someone. She married a male who does not have red-green color blindness, so that means he has a capital R, and then they had 3 offspring of their own. So they had 1 male, we have already labeled him with a lowercase r. We have 1 female that's a carrier, and so that must mean the other female is homozygous dominant. All right. Finally, we go over here to the left. The first offspring, the first female is a carrier. Again, she married a male that does not have red-green color blindness, but they do have children with red-green color blindness, so that must mean that they received it, the male received it from the mom. And so then our second male is going to have just a capital R. He got that dominant allele from mom. Our third offspring is a carrier, so we've already labeled her, and that must make our last female 2 capital R's. She gets 1 from dad and 1 from mom. Then finally, we go all the way to the right, and we have our middle square. This male, he does not have it. And so then we go all the way to the bottom, and we're left with 1 other male that does not have it. Right? And so just take your time when creating the next 2 pedigrees and assigning genotypes. Follow the directions, and when I return, we'll go over all these and practice a little more.